Hello everyone. In this video, we are going to discuss the question search a 2D matrix. And the matrix is of size m cross n. And we are giving we are given the matrix such as the row is sorted in non-decreasing order. And the first integer of every row is greater than the last integer of the previous row. So what we are given, let's see once. Suppose it is given that, suppose you have a matrix like this. Let's suppose this is the matrix of m cross n size, like m rows and n columns. And suppose you fill the integers like this: 1, 1, 2, 3, 4. It is given that every row is sorted in non-decreasing order. Like it is not decreasing, it is either increasing or equal. So yeah, this is sorted. We can say that it is sorted in ascending order, each row. And we are given that the first integer of every row is greater than the last integer of every row. So if this is 4, then this is definitely greater than 4. It can be anything greater than 4. Like let's take 6. Now, since this row is sorted, it will always like contain elements like this, isn't it? Now, the integer of this row is greater than this row, right? Integer of like this integer is always greater than this integer. So it will be greater than 9. So anything 11. But again, this row is sorted. The row is sorted individually. And the first element of every row is greater than the last element of every row. So this is how the matrix is filled. So can we say that the elements are sorted in this order? Just check once. Can we say that the elements are sorted in this order, like this? Okay, wait. Okay, just check this. First of all, it is sorted, it is going increasing like this. Now it goes to this first element, and again it is sorted like this. Again it goes to the first element, and it is sorted like this. Again it goes to the first element, and it is sorted like this. So can we say like this, that the array is sorted this way, then this way, then this way, then this way, isn't it? So yeah, we know how to search in a sorted array, right? So this is actually a sorted array. So what approach we are going to follow over here is, let's suppose this is the matrix. Okay. We will start from over here. We can start from anywhere, like from any of the, like from either from here or from here. Let's start from here. So we can, first of all, since we are searching for the element, we will keep the, like if this value is equals to target, we will keep a check. If this value is equals to target, we are going to return true. Now there are two, we are left with two cases, right? If target is like greater than this element, let's suppose this element is x, or if target is less than this element, right? Just see me one thing. If let's suppose target is greater than this element, that is, we are searching for an element greater than this. So we will get that element over here, or like in over here or here. What are the possibilities? There is only, like, this is not the possibility, right? We can't get our element over here. So yeah, we will get our element somewhere over here, isn't it? So what we will do is, like, we will, since it is a matrix, we will maintain two indices, I and j, which is denoting row and column respectively. So in this case, like if target is greater than x, we will just shift our column. Like first of all, our column was pointing over here. Now we will get our answer in this column, like in this column or the column away from this. We can't get our answer over here or over here, isn't it? So now the second case, like if the target is less than x. If the target is less than x, and we know that we have sorted our array something like this array is sorted like this, isn't it? So all the elements after this are greater than this element, greater than or equals to this. So we will never get an element in this row or in the below row which are less than this element, right? So what we will do is, we will just shift our row above. Like we don't have the possibility of getting the target if the target exists in this row or the row below this, since the elements are sorted like this, and this is the minimum element of this part. So if the target is less than this minimum element, so we will definitely get our element in the above row, or we will not get our element, and that are the two cases, right? So just we will shift our row. So yeah, this is the approach. Let's code it down. let's take the size. Like one is let's store the number of rows in this M and number of columns in N. Now let's initialize our starting value. We need to initialize both rows and columns. So the initial value of I we are keeping as n minus 1. Sorry, n minus 1, that is the last row, and initial value of j we are keeping as the first column, which is 0. Okay. So now while this I can go till like I can be greater than equals to 0. If it is less than 0, that is invalid case, right? And j can also attain like maximum value of n, n minus 1. It will not go beyond that. So we kept a check over here. Now there are like three cases. If target is equals to the matrix of I and j, like the present number, so we are simply returning true over here. And if we are left with two cases, like if target is greater than matrix of I and j. If this is the case, then we can definitely say like the element we are searching for, we will not get in this row or the above. So we will just shift our column to +1. And if opposite is the case, like target is less than what we are searching, and since we know that array is already shorted from this point of time, so we will just shift our column row to I minus 1. So I minus 1. So at the end, if we have not returned true till now, so we will return false. That is, we have not found the element. Let's see if it's working or not. Okay, it got. Let's try to submit it now. Okay, it's working. Nice. So I hope you all got the solution. Thank you.